We are at the Marvin Braud pumping station doing a velocity test. About 3 years ago, USGS asked us to build a platform on U River so that they can put a velocity meter in the station. Well, it only records from one side right now, but it does give me a good indication of what direction the water is going, the elevation of it. So it's a very important tool that I have to actually think about the pumps.
So that's got what's called a phased array on it, which is one transducer. Yeah. And then depending on the angle that the piston hits, it can change and create separate beams to watch what the velocity is doing. This has two eyes that look out at 25 degrees with a 6-degree spread. And so they go out and they get a velocity on beam 1 and a velocity on beam 2, and then rectify those to an X velocity in the center. And then you can see just a little red dot right there on top. That's your up-looking beam, so it provides a backup gauge height. So I'm not going to lift it because it's less forgiving, but this is a pressure transducer. So that gives me my primary gauge height, but just in case it were to fail, I've got that up-looking beam that actually pings off the water surface and it tells me a depth so that I can fill in there and so we don't lose phase.
Today they want to actually test all the way across the bayou. They're going to have a guy in the bow and he's going to have different meters going back and forth.
Yeah, so if you look on the front of the kayak, there's a piece of equipment called an ADCP, or an acoustic Doppler current profiler. And what that does is it just sends pings down to the bottom. It lets me do a map so I can do a cross-sectional area. And then it breaks each one of those pings up into what's called a bin, so little chunks of velocity data. And so in the end, we get some really pretty graphs that tell me just how much water is flowing through and where that water tends to actually be moving within the channel. And so from that, I get an actual snapshot of discharge. Then the gauge that we have has something really similar but not as advanced. It shoots a sound wave to the side that gives me velocities that are an index point. And so I can relate those index velocities to a true discharge. And so from that and then the gauge height sensor, we can compute discharge based off those two values. So we can compute an area and a mean velocity. So we're working on setting up a model based off some equipment that we have at the gauge over on my left so that we can develop a real-time discharge model. So every 15 minutes or so, we'll compute an amount of outflow that's coming through the pumps or just naturally back and forth in the tidal swing. And so it'll help to monitor how much water is coming through whenever they are running the drainage pumps.
Our goal is to run one pump, number 6, which is our newest model. I think it can turn up a few more RPMs and see if we can get a little better velocity than 1 through 5. We're going to run number 6 for 30 minutes. We're going to shut it down. We're going to turn number 5 on, which is one of the older pumps. We're going to run it for 30 minutes. We're going to shut it down. Then we're going to crank up 5 out of 7. That is the golden rule, to have 5 pumps running at one time. And we are going to run 5 pumps for 30 minutes. 1 through 5 at 960 RPM, it's low RPM engines. They are designed to move 448,800 gallons of water a minute. That's what they're designed to do. 6 and 7 is actually the same thing. We are going to turn number 6 and 7 up to 1,000 for their test. They both of them said, hey, it'll work, no problem. So it's just a difference in what they both can do. That's what we're main concern.
You know, discharge data plays a huge part in what goes on in Louisiana. We don't have a lot of slope, so water doesn't want to go a lot of places, right? And so one thing that you need to know is, are the pumps actually moving the water that we think it's moving? And so this is going to give you just kind of a validation point for that. It'll also show you when you start to get backwater. So even though the gauge height goes up and maybe you have velocity coming through the pumps themselves, the water may not be going anywhere because we don't have the slope. And so that's going to give you that data point also. It'll help to quantify just the backwater effect. And then just from general, not simply within the parish, but overarching, it's really interesting to see the way the water moves down here. And it'll help for future modeling. So this data becomes available to anybody who needs it for future levee modeling, or how flows are being affected in storm surge, because this data will always be here. It's going to capture any tide cycle. It's going to capture any rain.
It's important we do this to test the efficiency of our pumps is one thing. Another thing, to know how many CFs we are getting from our pumps. 1 pump, 2 pump, or 5 pumps. I'm hoping to get that calculation to come back to me. And a little bit on the fuel part of it, each one of them burns 66 gallons an hour of diesel. If we run 5 pumps, you can actually, in a 24-hour period, I need 10,000 gallons of diesel.
I'm pretty excited. We've been working for about a year to try to really get a rating, so it takes a lot of data points to create a model. And that high end is difficult because it doesn't flow real fast. So, thanks a lot to Alan and Roger both for taking the time to come out here and run the pumps for us when they could, so we can finish this and get some real data on the web.